Good morning, everybody. This is a quick little video to wrap up section 3.5 on complex numbers. The packet that I gave you guys in class basically just worked on how to do operations with complex numbers, how to simplify complex numbers. I don't believe that there were any problems, however, on what you actually use these numbers for. So before you dive into lesson 3.6, which has a lot more to do with complex numbers, I wanted you to do a few problems out of the book on how to express the complex solutions of a quadratic equation, which is basically where you usually stopped in Algebra 1. If we had some kind of a solution that had a negative number under the discriminant, that's of course the part under the quadratic formula. The quadratic formula, of course, is negative b plus or minus the square root of b squared minus 4ac. That was all over 2a, and I have my reasons for writing it this way because this gives me my line of symmetry. But this part here, the discriminant, is the test, so to speak, as to whether or not there are real solutions and how many solutions there are. If it's 0, we have only one solution. If it was positive, we had 2 real solutions. If it was negative, you stopped and said no real solutions. Well, now that you know how to handle complex numbers, we now can express a solution in complex number form. So there's a few examples on page 267 of your book, and I just thought I'd take 5 minutes to go through these examples and kind of explain them to you. I know the book sometimes isn't the easiest to follow, but once you get the hang of it, they're pretty easy. The other thing I actually don't much care for about the book examples is their immediate jumping to the quadratic formula to solve these equations. Very often, completing the square is just much simpler and cleaner and easier. So I'm just going to show you a couple of those techniques. So the first example, one of the easiest ones, is if you have a quadratic of this form. And of course, we know what to do with a difference of squares, right? But this is not a difference of squares, it's a sum of squares. And you're going to start noticing a pattern with these now that we have these complex numbers. But this is not a difference of squares, it's a sum of squares. So of course, to set this equal to 0 to solve, we end up having to set x squared equal to negative 9. If I take the square root of both sides, I end up with x is the square root of negative 9. By now, however, you should know that I can pull out that negative 1 and express that as an I times the square root of 9, which would be 3. And of course, by convention, we would write that as 3i, but we also have to remember that when we take the square root, we've got a plus or minus. Okay, so our final answer is plus or minus 3i. So in this case, if I were to graph this x squared plus 9, of course, it would be a parabola floating above. This would be 9, right? However, in this particular case, we can say now that we do have complex solutions. We're not limited now to the real number world. So this is the simplest case. The second example is, again, something that might look factorable, but it's not. Of course, if that were a negative, we could, because positive 5 times negative 1 would give me negative 5 and add to 4. But because I've got positives all the way through, if I were to set this equal to 0, I'd have a negative on the other side. In the book, they actually solve this with the quadratic formula, but as you can see, it's actually much easier if you complete the square. Of course, half of that and then square it is 4. You should probably be recognizing this one by now. If I add 4 to this side, I have to add 4 to this side. Of course, I have a -5 over here because if I set this equal to 0, move the 5 over, I've got -5. So this, we now recognize this. We've created this perfect square pattern. We've got x plus 2 squared equals -1. When we take the square root of both sides, we get x plus 2 is equal to plus or minus the square root of -1 is I. So the solution is -2 plus or minus I. And that, frankly, in my opinion, is much simpler than cranking through the quadratic formula. So anytime I think that you have a fairly simple situation of being able to complete the square, your answer is going to come out much easier. And a really good example of that is if you turn the page in your book to page 268. And if you look at the example there, again, we've got, here's the polynomial. Let me write this out for you. It's 4x squared minus 24x. And instead of writing the plus 37 over here, I'm going to do equals -37. I've been doing the way that most of you are more comfortable with completing the square. But this is my way of setting this polynomial. It was plus 37, okay, equals 0. And hopefully you'll understand that if I move my 37 over, I'm subtracting 37 from both sides. So that's how I've set this one up, okay? And you might say, well, why would you complete the square? Well, obviously, because it's real easy to factor out this 4. That's why I'm doing it, okay? So I'm going to do it 4x squared minus 6x. Half of 6 is 3. Square it plus 9 equals -37. Now I have to look at what did I add here, because I need to add the same thing over here or my equation is not in balance. I added 4 times 9, that's 36. And you can see how nice this comes out to be. I end up with 4 times x minus 3 squared is equal to -1. And if you look at the example, you know, they've got numbers like 4 times 4 times 37 that you've got to use your calculator for. You're subtracting, you've got negatives and positives. I just find this to be easier. It's cleaner. So anyway, before I take the square root, I'm going to move my 4 over, so I just have this before I take the square root. So I end up with x minus 3 squared is equal to -1/4. And of course, I'm going to take the square root to get rid of my square. And I end up with x minus 3 is equal to, of course, remember I can unbundle this radical. So this becomes I, square root of -1 becomes I over 4, square root of 4, which is 2. Okay, so my final answer, when I add 3 over, is, and I should have said plus or minus, is 3 plus or minus I over 2. Or another way of writing it would be plus or minus 1/2 I. There's, you know, different versions of this, but I kind of like this as the most simple form. And if you compare this to the solution in the book, particularly since we have I here and our calculators don't handle that very well, I just find this a much cleaner and simpler way to do these kinds of problems. At this point, you would go and do your homework problems. There's 4 of them that I've asked you to do that involve taking a quadratic and expressing the solutions in complex numbers.